Sound and music are all around us. But how do these devices turn electricity into a symphony of sound? And really, why does anything make sound at all?
If you guys need a refresher on how electromagnetism works, check out this video here. To understand how everyday devices make music, we first need to understand vibration and movement.
And there are many ways to use electricity to make something move.
But digital audio is made in a different way. You see, these here are pretty much just giant versions of what's inside of here. Now, these here that we call solenoids are really just tubes that I wrapped wire around. When I put inside a permanent magnet, I can make it shoot out when we turn on the electromagnet. You can cause this to shoot out if they disagree, or you can cause it to become attracted and get pushed back down if they agree. You might think this one has more wire than this one, but if you look, this one's just really shallow. So the amount of wire is actually the same across all of these, meaning they're actually the same strength. However, one of these will get shot out faster. Do you know which one?
To understand what's really going on, you're going to need to see the field created by our solenoid first. Let's ignore the direction of the field and look only at the magnitude. Then we get this nice potential graph that looks like a hill. The smaller permanent magnet moves as if it's rolling down this potential hill. That's everything you need to know to make your guess about which one of these will go faster and further.
Now, when I go back to the setup and just show you the hills to begin with, the answer is going to become obvious. So how do we use that to make sound? Basically, we're going to do the same thing and just wind it really tight. We put a magnetic plunger on top, and then by switching the polarity of the magnet, we can make it go out or come back in. You see, that ability for them to move either direction makes them perfect vibrators. Now, the notes that you're used to hearing are just what happens when these vibrations happen at very specific frequencies. However, something this small, you can't really hear the sound that it makes. So, you have to attach something called a resonator. Any object which vibrates violently when exposed to a specific frequency is a resonator. Each segment of the can has its own resonant frequencies. The sound is loudest when the incoming frequency and the resonant frequency match. Or, in the case of harmonics, is a multiple of the resonant frequency. When you strike a resonator like a drum, it excites all of those frequencies at once, and that's what gives the can a specific twang whenever you hit it. However, if you vibrate at just one of those frequencies, you'll get a specific note instead. If you'd like to pick up your own metal orchestra, check out the link in the description. There's build files, listed materials, along with build instructions. Or, if you'd like to pick up a pre-assembled one, you can support us at our website below as well. So the next time somebody tells you magnetic fields just aren't important, tell them you're not going to hear their nonsense.